Okay, today we're going to decide if a table of values is linear. That's what we're working on for today's little assignment. So we're going to be first working in our math notebook. So make sure you have your math notebook available because we are going to be writing a few things in there. The first thing, we just want to do a little memory things here. From our last unit, we learned that if a graph was going this direction, it was increasing. And we're writing this in our math notebooks now. This is the part we're putting in there. When we see a line that looks like this, and we know that it's increasing, that means it's going up. So up obviously means something positive. So our rate of change or slope, because right now we're calling it rate of change, and in the next unit we are going to be calling it slope. So the rate of change or slope is going to be positive. So that means when you're finding your rate of change from points or from values or from a graph, knowing the direction of the line is important. So if I'm looking at a graph, a problem where I'm trying to find it from a graph and I see it going this way, I know my answer is going to have to be positive. If it goes the other way though, from our unit, we know this is decreasing. So if it's decreasing, that means that our slope is going to be negative because it's going in this direction. So if I am taking rate of change from 2 points in a graph, I know if it's going this way, my answer has to be negative. And the ones we've been working with, if I have a graph and I have this, we know this is a vertical line. And I can do this one with absolutely positively no math involved at all. If I have a vertical line and I actually do the math to get the rate of change, I'm going to find that I'm going to have some number like 10 over 0. I can't do that. And in my calculator, I'm going to get an error message because I can't take a piece of pizza and divide it in 0 pieces because I know I'm still going to have a piece of pizza. So there's no mathematical way to do that, so we say that that's undefined. And our last one goes like this, and we all know this is a horizontal line. So anytime we see a horizontal line, we can do absolutely positively no math. We see that horizontal, we'll go bam, we know that the slope or rate of change is going to equal 0. We do that without any math involved. These two we can do. Now I'm hoping that you have paused this little tape in between so that you can write all of this in your math notebook. So the next part we're going to do on our math notebook, you will have gotten from me a little piece of paper that has 2 little charts on it. You're going to glue them in. So I'm going to pause for a second while you glue that one in. We're going to do something different with this. Now, up until this point, I've said, oh, just use any 2 points. So when we're trying to find rate of change or slope, and you're writing this in your math notebooks, rate of change or slope, normally we would just take our 2 points, subtract, do our subtracting thing, and be done. However, now we want to decide if the table of values is linear. We have to do a little more work. We're going to have to compare more than 1 point. So now this time it's going to create a little bit of work. And I do know that there's 1 or 2 test questions that have this, so we're going to have to make sure we know it. So we're going to first compare our first set of points here, our 2 and 14 and our 5 and 35. So we're going to just do our normal x and y. So my first pair is 2 and 14. My second pair is 5 and 35. So we'll write that down. And I am a big proponent of using a calculator to do this stuff. So I'm going to go ahead and I'm going to do my math. 14 minus 35. And I'm going to get a negative 21. And 2 minus 5, which you're doing with me on your calculator, and get a negative 3. Double negatives. The minute I see that, I know my answer is positive. But we're still going to go out and do our 21 over 3. I changed it to positive because I know it's positive. So now I'm going to see if I can decrease this, and sure enough I get a 7 for this one. So now I'm going to do the next set of points. I'm going to do this set. So now I'm going to do 7, my x, and my y, and my 5 and 35. It doesn't matter which order. You could have done 535 and 749 and you would have still been okay. I'm going to go ahead and I'm going to do my math. 49 minus 35. Get 14, 7 and 5, and it was 2. So I'm going to put my y over my x, and sure enough I get 7. These match. So the minute they match, it equals a linear equation. And we learned in the last unit that linear means straight line. So if we were to put these onto a graph, it would create a straight line. So the next little bit you're going to do today, that's what you're going to be determining. So let's look at one more example. So you're pasting your next one in. And I'm going to give you a second to do that. Okay, should have that glued on now. So we're going to do the same thing. Going to compare our first set of points. So I have 2 and 48. Sorry about my puppy barking. And negative 1, negative 24. So we're going to go ahead and we're going to subtract those out. Use your calculator to do that. And when we have those negatives, we need to use our calculator, because the biggest problem I was finding from all of you is that you weren't using your calculator, and that's where you were making the mistake. So in my calculator, I'm going to put 48 minus negative 24. I'm going to put that right in because we want to use our brains, and you have such fabulous brains, but when it comes to those negative numbers, that's where you're making your mistake. So we got 48 minus negative 24. We're going to find it 72. Some of you that used your brains and not the calculator forgot about that double negative thing probably got 24. So make sure you use your calculator. So now I'm going to get 72 over 3. This is the thing we've been doing all this time. I'm going to see if I can reduce that. I sure can, and I get 24. So now I'm going to do my next set of points. Usually you only have to do 2. Sometimes you have to go as far as 3 to be able to double check your work. So I got 90. Boy, I'm making that same mistake a lot of you make, and wrote it backwards. I've got 4 and 90. Let's scooch that up a little bit. And I'm going to bring this down. We have 2 and 48. Make sure you keep those ordered pairs together. So now I'm going to go ahead and do some subtracting. 90 minus 48. I get 42. And 4 minus 2, I don't need my calculator for that one. 4 minus 2 is 2. So now I'm going to do 42 over 2, my y over my x. 42 divided by 2 is going to give me 21. We notice this and this don't match. So the minute you see them not match, you know it is non-linear. Doesn't make a straight line. So now you put this in your math notebooks. You're going to use these 2 examples to help you work on the assignment. Please look at your Google Classroom to know there's an assignment in the skills practice book, as well as a little quiz you're going to take on some things that you've done all this week, as well as what we've done today in this part on seeing if they're linear or non-linear. Piece of cake, because you already know how to do this from table. So if you have any questions, let me know.